What we're going to do today is the last section in Unit 5. I'm hoping that Unit 5 has given you a chance to sort of take a deep breath after Unit 4, which was certainly the hardest unit we've had so far this semester. And Unit 5 is going to end with vectors. So we really only have one last section to cover together before we do our practice assignment and do our test. And again, what I've done for 5.3 today is I've looked at your 10 questions on your quiz. I have picked out quite a few questions to do with you, but I've just changed the numbers. So if you're taking really good notes today, you will do just fine on your quiz and then on your upcoming test. So let's try some. Vectors. A vector, have you guys learned about this in physics? Mr. Hayden said he's already done it this semester. You guys have covered vectors a little bit. Vector, and Stefan, I'll come back to your question at the end, okay? A vector has both magnitude and direction. So when I'm looking on my graph, and they always represent a vector as an arrow. So this vector has magnitude. Magnitude is just the length of the arrow. And direction means it points in a specific spot. So it might point 25 degrees, because we always assume that the x-axis that's positive, that's always where we start from 0, just on a unit, like on a unit circle. So a vector would have magnitude, which means the length of it, and it also has direction, meaning a degree. So how we're going to solve for the magnitude of a vector, again, when we see the absolute value symbol, it's not really absolute value, it's going to be magnitude. It's just the Pythagorean theorem. Very cool. So we're going to try one in just a minute. So let's try one. It says, what is the magnitude? Or they could ask you length. So length and magnitude can substitute for each other of the vector 3, 2. So let's all practice this one together. If I want to know the length or magnitude, remember we can write it as absolute value of v. So what it's telling us to do is we're going to square the first term, we're going to square the second term, and that's going to be the magnitude. So the magnitude is the square root of 9 plus 4, so square root of 13. And that's your length. Oops. My pen went all crazy there. Any questions about how I did that one? So it says, what's the length? Length means magnitude. How do you find magnitude? You square the first one, you square the second one, you add them together and take the square root. This is just Pythagorean theorem. Right? It's just this portion right here. So it's where we get the c equals square root of a squared plus b squared. So if I say what's magnitude, or how do you find magnitude, we find magnitude with the Pythagorean theorem. Questions on this first one? Yep, this is definitely part of the essential question. So let's keep chugging away and we'll try some more. So again, magnitude just means length. How do we find the magnitude? We use the Pythagorean theorem. Okay, a couple things they're going to have us do with vectors. We are able to add vectors together. It's actually a very simple process, but what I like that your online lesson did is they gave you a picture of it. So if here's your vector 1, and here's your vector 2, to add them together, it's really the diagonal. If we were to make this a parallelogram, see how here's V1, if I added another V1, if here's V2, and I add in another V2, the sum is actually just the diagonal of that parallelogram. This is not something you have to memorize or anything. I just wanted you to get a visual with what we are going to do mathematically in just a moment. So let's try this one. What's the sum of two vectors? 4, -1 and 3, 9. Can somebody type in, how do I add vectors? What do you guys think? It says sum. How do I add vectors? And it's okay if you haven't tried this lesson yet. Okay, so one way we do it, we are going to add x with our x, then we're going to add our y with our y. So let's sum these two vectors together. So 4 and 3 would be 7, -1 and -9 would be 8. So that is the sum of your vectors. Everybody okay? It didn't say magnitude this time, so I'm not using Pythagorean theorem. If it says sum, sum just means add. Are we okay with the difference now? I don't want us to overthink this unit because this unit is so easy. Okay, so sum just means add. X's with x's, y's with y's. Everybody okay with how I got 7, 8? Yes, are we okay? Or do we have a question? Okay, great. Now the difference of vectors, let's take a peek at this one. If here's my vector 1 and here's my vector 2, the way that you find the difference of vectors, this is just again from a picture standpoint, if I were to connect tip to tip, the difference of vectors would be the one where I move it down to the other end, to its vertex basically. And this time V1 becomes the diagonal. So all your online lesson was trying to show you is that all of these things can be shown geometrically, and they're always a parallelogram. But again, you don't have to memorize that. I just kind of wanted to point out that that's what's happening graphically when we're finding the sum. Remember, the sum's going to go in between the two. And when we find difference, the difference is going to be an offshoot of it. So like if we take V2 and we drew in another V2, your V1 is actually the diagonal. Let's try a difference problem. There are actually two separate things going on here, so let me give you a minute, copy that down. This time I put a number or a coefficient in front of the coordinate. Do you guys see that? I put a 3 in front of the 2, 0. I put a -4 in front of the 2, -1. So before I even begin, I need to multiply this first vector by 3. So let's do 3 times 2 and 3 times 0. So I would get 6, 0. Everybody okay so far? So far so good? Okay, great. Now for the next one, let's actually multiply through by the -4. So let's say I'm going to get -8 and a +4. When I multiply through by the negative, this is really becoming an addition problem now. So just like what we used to do in math a couple units ago, how when you distribute the negative, it becomes a plus in between. That's what's happening here. So I'm going to do my x with my x and my y with my y. So that would be my difference of vectors. So we kind of did two problems in one here. We first multiplied by a coefficient that's out in front. So we're amplifying it, we're making it bigger. This one was multiplied by 3, this one was multiplied by -4. That turned it into an addition problem because I got rid of that negative by distributing. Then I did just like we did on the last slide, x's with x's, y's with y's. Any questions on how I got here? Are we okay so far? So that's 3 questions on your quiz out of 10. 3 out of 10 are just like this. So far, everybody has an A+ on their quiz. Now I'm going to teach you a really cool thing called the dot product. So go ahead and write the word dot product. And then I want you to write the formula right here. So we're going to write dot product, and then we're going to write the formula. And that's all you need from this whole slide. I know that the online lessons are very wordy at times, so I'm just breaking it down for you here. And I'm going to show you how we apply this. All I want you to do is when I give you 2 vectors, a vector 1 and a vector 2, and think of Vectors are just coordinates, but remember, a vector has magnitude and direction, so that's the only difference, but they're going to look like coordinates on paper. So all I do with my two vectors is I'm going to multiply my x times my x, see just right here. Then I'm going to add that to my y times my y. Very simple. This is called dot product. So you will use this method when it asks you to do the dot product or when your problem is written like this. Can you also add that to your paper? When it's written like this with a dot in between, that means you have to use the dot product. So let's try one. Evaluate the dot product. So here are your two vectors, vector 1 and vector 2, so write those on your paper. And remember what the dot product is. It's just x times x plus y times y. So let's fill in my numbers. So I have a -1 times a 4, and I'm going to add that to my y times my other y. So I'm going to get -4 plus 6 is 2. That was a lot of complicated words on the last page just for us to do this simple mathematical problem. Are you guys on the same page as me? Are we okay with how I got 2? I want you guys ending Unit 5 saying, this is not so bad. I can do this stuff. Okay, so if this was V and W, I could write it like this, V dot W, and that would mean use the dot product, or I could just write it like this. And even without the dot in the middle, remember, when there's no dot, there really is a dot if they're touching, right? Because that means multiply. So if it's written with the dot, you use dot product. If it's written like the multiplication, you still use the dot product. Everybody okay? So if it says V times W, you can't just multiply them. You have to use this format right here. So we're going to practice again on the next slide. You guys are doing great. There's this cool thing called the orthogonal test. So let's write that word down. Orthogonal equals perpendicular. Orthogonal equals perpendicular. That might just be a quiz question. So think about what two perpendicular vectors would look like. One would be going in one direction, one would be going in the opposite direction, and they would have to be exactly at a 90 degree. Everybody okay with that, right? Old school perpendicular. They're going to meet each other at a 90 degree. So for me to check if two vectors are perpendicular, my V1 times my V2 must equal 0. That's the rule. That's what we're going to check in just a minute. So write that rule down. V1 times V2 must equal 0. How do we multiply two vectors together? You use the dot product. So down here, for this first question, we're going to check and see if 2, 6 and -4, 2 are orthogonal vectors. Notice they don't even use the word perpendicular. They're assuming that you know orthogonal equals perpendicular. So what am I going to do to vector 1 and vector 2? I'm going to multiply them using the dot product. So that means, again, x times x plus y times y, and I want it to equal 0. Because if it equals 0, then that means it's perpendicular. So let's try this one. So is 2, -4 plus 6 times 2, does that equal 0? I'm going to put a little question mark above it because that's what we're checking, right? So 2 times -4 is -8. Is -8 plus 12, does that equal 0? What do you guys think? No way, right? It's a 4. So if we say no, are these orthogonal vectors? No, they're not, because they didn't equal 0 when I did the dot product. Everybody okay with how to check that? Let's get a little more complicated. Let's throw some square roots in there. What about negative 4 square root 3 comma negative 4 and 2 root 3 comma negative 6? Are those orthogonal vectors? Let's check. Let's do x times x plus my y times my y. So over here, remember we do outsides with outsides, insides with insides. So negative 4 times 2 is negative 8. Root 3 times root 3 is root 9, because 3 times 3 is 9. But we know the square root of 9 is 3. So this is really negative 8 times 3. Is negative 8 times 3 plus 24, does that equal 0? Yes, it does. So are those orthogonal vectors? Yes, they are. So on your quiz, this is going to be one of those questions where they say, check which of the following are orthogonal vectors. They're going to give you 4 choices, and you're just going to check mark the ones that are a yes. Okay, so really easy. You're just going to have to check them just like we did in each case. So the top one would have been a no, bottom one would have been a yes. So now you guys are good with that vocabulary, correct? Everybody good? Orthogonal? Okay, we are almost done. You guys are rocking it. Yeah, this section's not bad. It's not bad at all. Projection. Okay, this is where this is as pretty much as hard as it gets for Unit 5, but you guys are going to be just fine. So I want you to write down the word projection. And let's write down, we have 2 formulas. Scalar projection is this one right here. And then it has scalar projection multiplied by the unit vector is right here. So let me give you just a quick minute to copy those couple things down, and then I will show you how to apply them. So what they're showing you in your online lesson is what projection actually is. So let me give you a little quick demo up here in the corner, just so you guys have an idea of what they're talking about here. If I have this vector right here, let's just call that vector 1. And then I have this vector right here. Let's call that vector 2. Projection means vector 1 making a 90-degree with vector 2 is actually asking you for what's the length from here to here. That's kind of what projection is. They talk about it being a shadow in your online lesson, but anytime they're saying projection of vector 1 onto vector 2, they're talking about if you're taking vector 1 making a 90-degree with vector 2, what's that length? That's all projection means. Projection of one vector onto the other vector. So let's think about this. It looks kind of scary at first, but it's not bad. Okay, think on top. On top, this is just going to be the dot product. Everybody okay with that? They have the dot between them. So dot product, meaning x times x plus y times y. Easy. On the bottom, this stands for magnitude. So how do we find the magnitude again? This was from our first slide. It's the x squared plus y squared, the square root of that answer. That's the Pythagorean theorem. So we're going to do dot product on top, Pythagorean theorem on the bottom. So we're going to try one together. We ready? And then I'll talk about how you take this and come down here. Let's see, is it v squared? Is that what you mean? Is v squared the same as w? Is that your question? I'm just making sure I understand your question correctly. It'll make more sense when we put numbers to it, because remember, v is going to be your first vector, like this, a vector, and w is going to be another vector, like this. So it will make more sense once we add numbers on the next slide. So v is going to be different than w, so it's not going to be v squared, because v and w are going to be different numbers. So let's try one, and then if you still have a question, we'll come back to it. So let's try this one right here. What is the projection of 3, 4 onto 3, 1? So let's just write down our 2 vectors for now. In the formula that they give us, there are V's and W's. So we're going to say that our first one is our V, the second one is our W. Anytime it says this onto this, the second one where it's going on to it is always your W. So that word onto is important. It's going on to W, onto the second one. So let's come back to our formula and let's see if we can figure out what they're wanting us to do here. So on top, they want V, P stands for projection, by the way. On the top, they want V times W. How do I figure that out? That's our dot product. So let's work that out together. That's our X times our X plus Y times Y. So X times X plus Y times Y. Can I give a check mark if you guys are good with how I got the top? Or ask a question if you still have a question. So the top, remember, if it's just multiplied, that means use the dot product. What's the dot product? X times X plus Y times Y. We'll simplify that. So 9 plus 4 is going to give me 13 on top. Now let's work on the bottom. The bottom doesn't mean absolute value of W. It means let's find the magnitude of W. So it's talking about W only. Everybody okay with that? The bottom wants the magnitude of W only. So I'm going to circle that one. How do you find magnitude? It's the square root of X squared plus Y squared. So I'm going to get 9 plus 1. So I'm going to get square root of 10. Let's circle that portion of our answer. That's a part of our answer, but we're not quite done yet. Any questions so far how I got that portion? Okay, so let's take a peek. We just did number 1. We figured out what P equaled. Everybody good? Now we're going to try this second portion. What the second portion does is it takes the value that we found here and it's going to multiply it by our coordinate. So let's type in that formula. Let's write out what it's asking us to find, which is this. So P equals VW over W times W times W. And this is like it's a crazy looking formula, I know. So our VW on top we found was 13. Our W, by the time we found the magnitude, we got it to be a square root of 10. So I'm going to say square root of 10 times square root of 10 because on the bottom it's W times W, W times W. Now over here, this last W that they use, and they don't do a very good job of explaining this in the online lesson, this last W that they use is your actual coordinate here. Because this is going to be the value of our projection, and then we're going to do that times by the vector. So here's where we're going to put in our 3, 1. So let's see what we're going to have. So 13 on top, root 10 times root 10 is root 100, or in other words 10, times 3, 1. 13 divided by 10, I can reduce that to 1.3. And they actually leave their answer just like this. So they work out the entire projection in the very front to be a decimal, and then they're going to leave it times the vector itself. So this one's just a little bit trickier. It just takes some practice. There's not really any hard math there. It's just getting used to, okay, the top means dot product, the bottom means magnitude. Then after you find that, we have to plug it into our final projection formula, where this W, I'm even going to highlight it, this W is always your coordinate. If you want to make a quick note of that, this W is always your coordinate. Okay, so let's try a true-false question here. True or false? You divide by the magnitude of V. Looking at my first formula. True or false? You divide by the magnitude of v. Good job. Yep, it's false. You divide by the magnitude of w. That will be a true-false question on there. True or false? To find projection, you have to use the dot product. Is that what you need to do? I guess I could phrase it a little bit differently, but somewhere in the problem you have to use the dot product. And that would be true, right? They're just trying to make sure that you know if you see w times v, do you just multiply those two? No, you have to use the dot product. So just be very clear about which letters they're asking you for in the true-false questions, and I know that you can answer them correctly. Because we know that these lines don't mean absolute value. They might even ask you, does that mean absolute value of w? You'd say, no way, no. So any questions on this problem? Because that is it for the day. You guys did awesome. Again, this is as hard as it gets, doing the projection, where you find your dot product over magnitude, and then here you just plug in your other values, where your last one is your coordinate.